Hey Cam, what's up? I know a number of you are gone this day of class, so this is going to be a brief video about Coffe Cup Calorimeters. And a Coffe Cup Calorimeter is this. It's just two coffee cups, styrofoam, nested inside of each other. We'd put a set amount of water in there, so say 50 milliliters of water or 100 grams of water, whatever it is. And we can either figure out the specific heat of a metal, say, so put a hot metal in there and see what the final temperature ends up, and we can see how much heat was gained by the water. That'd be equal to the amount of heat lost by the metal, and we can figure out its specific heat. Or a lot of times we dissolve an ionic solid in there because those are usually endo or exothermic as they dissolve. So the problem we're going to do now is dissolving this in a Coffe Cup Calorimeter. So this substance either absorbs heat from the water or gives heat off to the water exothermically, and there'll be a change in temperature in the water. However much heat is gained or lost by the water equals the heat gained or lost by this substance as it dissolves. So our problem here is they're taking 1 gram of this substance, sodium chlorate, dissolving it in 50 grams of water and seeing what happens to the temperature. So if you look here, the temperature goes from 24.67 to 23.74. So the water's temperature goes down. That means the water is exothermically giving off heat, and this substance must be gaining heat endothermically as it dissolves, taking heat from the water. Again, styrofoam cups are used because they don't give off a lot of heat they don't absorb a lot of heat. There probably is some heat lost to the calorimeter, and there's probably a little bit of heat lost to the surroundings, although we do usually put a cover on this. So these are not perfect, obviously, but you can get a pretty good idea from this. So we're going to try and figure out how much heat is given off in this reaction when 1 gram of this dissolves. So just like we've done in the past, we can say that the Q of the water equals the Q, in this case, of the reaction, or this substance dissolving. But one has to be endothermic, one exothermic. Well, our water is going down in temperature, so it must be giving off heat. So that's going to be a negative value equals the Q of the reaction there. So first thing, let's figure out Q for the water in the calorimeter. Okay, so the Q of the water is our mass of water is 50 grams. Specific heat 4.18, so MC delta T final minus initial, so 23.74 minus 24.67, which obviously gives us a negative number when we subtract those. So our Q for the water is going to be a negative answer, and it's about a negative 194 joules. So that means that the water is giving off 194 joules of energy as 1 gram of this dissolves. So that means our Q of the reaction, in other words, the Q of the sodium chlorate, is going to be a positive 194 joules. It is gaining 194 joules. Now that is not per mole, which oftentimes we want to know. That is per 1 gram of sodium chlorate. If we had 2 grams of sodium chlorate, it would be double this amount. If we had 3 grams, it would be triple this amount. So this answer is per gram because that's how much they dissolved. A lot of times I'll ask you how many joules of heat are absorbed by this per mole. So we'd have to take this answer since it was per gram and multiply it by the number of grams in a mole for that. Next question is just a conceptual one. Wants to know, what if 30 grams of water was used in the coffee cup instead of 50? Well, there's going to be less water to absorb the heat. This would still give off the same amount of heat. Actually, it's going to still absorb the same amount of heat. So the water would have to change temperature a little bit more. So it'd be a bigger change in temperature if we only use 30 grams of water because there's less water involved in it. That's your first problem. Second problem. So this is page 2 of your notes. Again, this is page 2. Another Coffe Cup Calorimeter problem, a little bit different. We got 12.84 grams of magnesium sulfate, so they're dissolving an ionic compound in water. Magnesium sulfate dissolving into water produces those. So a lot of times that solution process is endothermic or exothermic. So they're dissolving in 250 grams of water, and it says 9.74 kilojoules of heat are evolved. That means that much heat is given off into the water. So that means that our Q of reaction, in other words, when the magnesium sulfate dissolves, is going to be a negative 9.745 kilojoules. It is exothermically evolving that much heat, giving it off. Well, that means the Q for the water is going to be a positive 9.745 kilojoules. So when 12.8 grams of magnesium sulfate dissolve, it's giving off that much heat, which is being absorbed by the water. That means our water's temperature must go up, must be gaining heat as it absorbs it from the magnesium sulfate. So the last question wants to know what is the final temperature here. So I'm going to do that up here so I have a little space. So if I want to know the final temperature of the water, I can go the Q of the water equals MC delta T. So we know the Q of the water is this many kilojoules. Remember though, our specific heat is in joules. So we need to change this into joules, so it would be 9.745 joules equals, we have 250 grams of water. Specific heat of water is 4.18. And we're going to say, what is the final temperature? So final minus our initial. So there's your setup. I will say when you only have one variable to deal with in temperature, I would do this. I would take your number over here and divide it by both of these. Divide both these over to this side, and then all you have to do is add your 23.76 over. So I'll let you guys do the algebra. You end up with a final temperature of about 30.08, I believe. No, excuse me, 33.08 degrees Celsius. So our water's temperature, as this dissolved, went up from 23.76 to 33.08, so about 10 degrees. That's it for Coffe Cup Calorimeters.